Hello students, this is Dilip Udhani, Assistant Professor at LG Institute of Engineering and Technology. Today I will teach you Legendre's linear equation. The standard form of Legendre's linear equation is an into ax plus b the whole raised to n multiplied by nth derivative of y plus an minus 1 ax plus b the whole raised to n minus 1 into n minus 1 derivative of y plus dash 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 plus a1 ax plus b into dy by dx plus a0 into y equals to q of x, where an minus 1 up to an a0 are constant values. Okay, so this is the standard form of Legendre's linear equation. To solve this type of equation, what we will do, we will let ax plus b equals to e raised to z. Now, taking logarithm both sides, we have z equals to logarithm of ax plus b, and we will let ax plus b into dy by dx, that will be a into dy, where this d, capital D, is equals to d by dz, and ax plus b the whole square, d square y by dx square, that will be a square into d minus 1 y, where capital D is d by dz. Similarly, ax plus b the whole cube into d cube y by dx cube, that will be a cube into d minus 1 d minus 2 y. Okay, now let's start some examples. That is example number 1. We have to solve this differential equation, that is 2x plus 5 the whole square d square y by dx square minus 6 2x plus 5 dy by dx plus 8y equals to 6x. Now you can see that the dy by dx we have 2x plus 5 the whole raised to 1, but d square y by dx square we have 2x plus 5 the whole square. So this is the Legendre's linear equation. So we will take 2x plus 5 equals to e raised to z. So making subject of x from this equation, we have x equals to e raised to z minus 5 divided by 2. And if we will take logarithm both sides, we will be having z equals to logarithm of 2x plus 5. Okay. Now replacing 2x plus 5 dy by dx by 2 into dy. Okay, where capital D is d by dz, and replacing 2x plus 5 the whole square d square y by dx square by this 2 square, that is 4 d minus 1y, where capital D is d by dz. Okay, now 2x plus 5 the whole square d square y by dx square, that will become 4d into bracket d minus 1y, then after minus 6 will be as it is. Okay, and 2x plus 5 dy by dx, that will become 2 times dy, so it is 2 times dy, and finally 8y, so plus 8y, and that is equals to 6x, and replacing x by e raised to z minus 2. Okay, now we have to simplify this equation. 4d into d, it is 4d square, minus 1 into 4d, it is 4d, then after minus 6 to 12d plus 8y equals to 6 by 2, the answer is 3, and into bracket we have e raised to z minus 5. Now this is 4d square minus 4d and minus 12d, the result is minus 16d plus 8y equals to 3 times e raised to z minus 5. Now we can see that this differential equation is of the form function of dy equals to r of z. So its solution will be given by y equals to cf plus pi, where cf is a complementary function and pi is a particular integral. So first of all we will find out cf. To find CF, we will equate function of d to 0. Here function of d is 4d square minus 16d plus 8 equals to 0. Now we will divide this whole equation by 4. So the result will be d square minus 4d plus 2 equals to 0. Now we cannot split the middle term 4d such that the product of two term is the product of two term is 2 and their sum is 4. Okay, right? So we will solve this differential equation using the concept of quadratic equation, and its solution is given by d equals to minus b plus minus square root of b square minus 4ac divided by 2a. Here the value of a is 1, b is minus 4 and c is 2. So minus value of b is minus 4. So minus minus plus 4, then after plus minus square root of b square, value of b is minus 4 and minus 4 square, that is 16. Then after minus 4, value of a is 1 and c is 2. So 4 2s are 8 and 16 minus 8, the result is 8. And square root of 8, that is 2 root 2. Now taking 2 common, so 2 and 2 will cancel out, the result is 2 plus minus root 2. So here we are getting two real values, 2 plus root 2 and 2 minus root 2. So CF, that will be C1 e raised to 2 plus root 2z plus C2 e raised to 2 minus root 2z. Okay. Now e raised to z the whole raised to 2 plus root 2, and e raised to z is 2x plus 5. Similarly here replacing e raised to z by 2x plus 5. So this is required CF. Now we will find out PI. Okay, right? Formula of Pi is 1 over f of d rz, and f of d is 4d square minus 16d plus 8. Okay, and rz is 3 times e raised to z minus 5. Now we will apply this operator on 3 e raised to z and 3 5 is 15. Okay, so we have 3 e raised to z over this function, then after minus 3 5 is 15 over this function of d. Now this is case number 1. The value of a is 1, so replacing d by 1. So 3 e raised to z will be as it is, so it will become 4 minus 16 1 is 16 plus 8, and over here writing e raised to 0 z, so value of d will become 0, so replacing d by 0 we have 15 by 8. Now 4 plus 8 is 12, and 12 minus 16, answer is minus 4. Okay, so this is minus 3 by 4, taking minus 3 by 4 common, this will become e raised to z minus minus plus, and here it will be 5 by 2. Now replacing e raised to z by 2x plus 5 plus 5 by 2. Now we will simplify this result taking LCM 2 and multiplying 4 by 2. So this is the required Pi minus 3 into bracket 4x plus 15 divided by 8. So this is the required general solution, y equals to CF plus Pi. This is CF. Okay, we have taken it from this one, and the Pi is this one. Okay, so this is the required general solution of given differential equation. Now we will see second example, that is this one. Again you can see that with dy by dx we have 1 plus x the whole raised to 1, and with d square by dx square we have 1 plus x the whole raised to 2. So this is Legendre differential equation. So let 1 plus x equals to e raised to z. Now taking logarithm both side, we have z equals to logarithm of 1 plus x, and replacing 1 plus x dy by dx by dy, because the coefficient of x is 1 and here 1 into dy, the result will be dy, and replacing 1 plus x the whole square, d square by dx square by 1 square dd minus 1y, and the 1 square is 1, so replacing this function by dd minus 1y. Okay, now replacing 1 plus x the whole square y double dash by dd minus 1y plus replacing 1 plus x dy by dx by dy, and this plus y will be as it is, and then after in the right hand side we have 4 cosine of log 1 plus x, that is z. So in the right hand side we have 4 cosine of z. Now we have to simplify this result, d into d square minus 1 into d minus 1d, then after this plus 1d plus 1y equals to 4 cosine of z. Now minus d plus d will cancel out. We have d square plus 1y equals to 4 cosine z. This is of the form function of dy equals to rz. So its solution will be given by y equals to cf plus pi, where cf is a complementary function and it is given by equating function of d to 0. Function of d is d square plus 1. So equating this to 0, we have d square equals to minus 1, and minus 1, that is nothing but I square. So we have d square equals to I square, and I square, so d will be plus minus 1i. So real part is 0 and the imaginary part is 1. So CF is C1 e raised to 0z cosine of 1z, but e raised to 0z is 1. So no need to write down 1, plus C2 e raised to 0z sine 1z. Again e raised to 0z will become 1. So no need to write down 1. Now replacing z by logarithm of 1 plus x. So CF is C1 cosine of logarithm of 1 plus x plus C2 sine of logarithm of 1 plus x. Okay. Now pi is 1 over f of d rz. F of d is d square plus 1. That is this one. Okay. And rz is 4 cosine of z. Now this is case number 2. This is 1. So replacing d square by minus 1. So it will become 0. So what we will do, we will differentiate d square plus 1 with respect to d. So it will become 2d and multiplying numerator by z. Now 4 by 2 is 2. Z will be as it is, and 1 over d, that is integration. So integration of cos z, answer is sin z. So pi is 2z sin z, but we will replace z by logarithm of 1 plus x. This 2 will be as it is, into sine of replacing z by logarithm of 1 plus x. So the general solution, that is y equals to cf plus pi. Okay, and cf is c1 cosine of log 1 plus x plus c2 sine of log 1 plus x. Okay, that is this one, plus pi, that is this one, 2 logarithm of 1 plus x into sine of logarithm of 1 plus x. Okay, so today we have discussed Legendre differential equation. Okay, thank you for watching this video.